The last operation that we have not talked about yet is division. And I think I mentioned to some of you guys that most of the division in polynomials is done in Algebra 2. However, there is a simple process of division that we are going to talk about this year. In Algebra 2, they do the traditional long division, you know, where you make the little hut and you divide things into the first piece and you have a remainder and all that kind of stuff. But another technique to use is when you have a division problem, is you factor the top and you factor the bottom. Of course, factor means you're looking for things that multiply together. 2 times 3 times 4 are all factors because they're being multiplied together. 3 and 5 are factors because they're being multiplied together. Of course, the bottom is equal to 15, and 2 times 3 is 6, and 6 times 4 is 24. So this is actually 24 over 15. But if I factor it down into little pieces, factors can cancel out. If you have the same number on top as on bottom, and they're all being multiplied together on top, and they're all being multiplied together on bottom, the whole factor can cancel out with the whole factor on bottom. So this 3 cancels out with that 3. So then you have left 2 times 4 is 8 on top, and you have 5 on bottom. So 8/5 would be the answer to this division problem. And if you do, excuse me, 24 divided by 5, you could get long division and do it in long division format, or you can do it as a fraction and reduce the fraction down. So basically what we're going to do is leave them in fraction form and just kind of reduce them down. So the key is to factor the top, factor the bottom, and see if there are any things that are being multiplied together that can cancel out. So we're looking for factors on top and factors on bottom. So if I just look at the top part only, 3x plus 18, when we are factoring, my first step on factoring is to look for a GCF. So are there x's in both pieces on top? No, there's not. And then I look to say, okay, is there a number that will go evenly into 3 and 18? Well, the only number that goes evenly into 3 besides 1 is 3. And 3 does go evenly into 3, but does 3 go into 18 evenly? It does. So I'm going to rewrite this as 3, because 3 is the GCF, and 3 times what is 3x? Well, I need to have an x here. 3 times x will give me 3x, and 3 times what will give me 18? I need a positive 6. So if you had this problem, 3 times x is 3x, and 3 times 6 is 18. Here it is in factored form. Here it is as the product. So again, all I did was take this original problem and factor the top. So there's the top being factored. We've pulled out the GCF. And again, I want to factor the bottom. So 2 separate problems. Factor the top, factor the bottom. Start with the GCF. Are there x's in both pieces? No, can't pull an x out. But is there any number that will go evenly into 5 and 30? You're right. 5 will go evenly into 5 and 30. So 5 is your GCF. We pull it out, and then we think 5 times what will equal this? Well, 5 times x will give me a 5x, and then 5 times what will give me my 30. I need it to be a positive 6. So 5 times x is 5x, 5 times 6 is positive 30. So you kind of check, make sure the math is right. Now, when you look at this new factored version of this, can you see that there are 2 factors, one on top and one on bottom, that are the same? And this whole thing is a single factor. This whole parentheses is one single factor. So either the whole thing goes or not. You can't pull a piece of it out. You can't say an x and an x cancel out. It's the whole x plus 6 cancels out with this whole x plus 6. So don't try to break them up. Everything inside that parentheses has to go together all at one time. So 3 over 5 is what's left. 3 over 5. So 3/5 is the answer to this. If you were to do long division on that, you would also get 3/5 when you do that. Okay, third example. Same thing, we're doing division, so this is like a fraction. We want to simplify it down, which means I want to cancel out factors. So I'm going to factor the top, factor the bottom, and see if there's anything that can be pulled out. Now this one always looks like it's factored because it's this times this. Now you can also double check to make sure that none of these can be factored. Are there x's in both pieces? No. Is there any number besides a 1 in front of this one? No. Are there x's in both pieces? No. Is there anything besides a 1 in front of this one? No. So there are no GCFs in either one of these down here. They are factored as far as they can go. So it's just that times that. So we got 2 factors on bottom. So I don't have to factor it, but I do need to factor on top because this is a lovely trinomial, and I'm thinking, ooh, could be a binomial times a binomial. And I check for GCF. There are not x's in all 3 pieces, and this has a 1 in front of it. So the only thing that will go evenly into all 3 numbers, 1, 3, and 2, is 1. So there is no GCF, but you always check that first, like we did in the first example, or second example. So I'm going to factor this into a binomial times a binomial, hopefully. So then I look for factors of 2. So I have 1 times 2. And if I add them together, do I get a 3? Yes. And get a positive 3, I think they both need to be a plus and a plus. And so this means this is x and x at the beginning. And I have a +1 and a +2. Here we go. And of course the bottom is still x minus 4. and x plus 2. So notice these two things are being multiplied together, those two are being multiplied together. This whole factor, x plus 2, can cancel out with this whole factor, x plus 2. So either the whole parentheses goes or nothing goes. That whole parentheses is just one factor. So when you're done, you're left with x plus 1 on top, and you can leave it in parentheses if you want, and x minus 4 on bottom. Now you may say, well, how come I can't cancel out the x and the x? Because remember, they're inside parentheses. Either the whole thing goes or nothing goes, because this is addition. You can't factor out, or you can't cross off things that are being added and subtracted together. You can only cancel factors. And factors are things that are multiplying together, and these two things are not being multiplied together. Had this been x times 1 and x times negative 4, then yes, then the x's could cancel out. But these are not factors. The whole thing is a single factor. So if you want to remember that, that whole thing is a factor. And so unless I have another x plus 1 on bottom, it can't cancel out. Unless there's another x minus 4 on top, they can't cancel out. Okay, so that's the only tricky part. Some people like to try to cancel out these x's, and you can't do that. All right, so either the whole thing goes or nothing goes. Number 4. So go try one of these on your own, see how you do, pause the video. Try this one, remember look for GCF first, and then check your answer. All right, hopefully you pause and you come back. There is a GCF on this top part. What will go evenly into 4 and 28? 4 will go into both of them. And there were no x's in either piece, in just both pieces. There's only an x in one, so they can't pull the x out. 4 times what is 4? I need an x there, a 1x, because 4 times 1x is 4x. 4 times what is 28? I need a negative 7. So this is being factored now. If I multiply these two pieces together, it equals that. Factor the bottom, I think I can pull a 5 out. 5 will go evenly into both 5 and 35, so that's my GCF. I always look for that first. And of course, 5 times x is 5x, and 5 times a negative 7 will give me a negative 35. And lo and behold, x minus 7 will cancel out with x minus 7. They are the same. So I've got the same factor on top as on bottom. That leaves me with 4/5 is the answer to that division problem. So that fraction line is a division problem. Number 5. Again, it's a division problem, so the only way we're going to do these are to factor the top, factor the bottom, and cancel out anything that's the same on top and bottom. Okay, so this looks like it's already factored on bottom, so I don't have to factor it, but I do need to factor on top, so I still have 5 minus, I should say, I can't write and talk, so it's x minus 1 on bottom and x plus 1 on bottom. Just pretend that first one's a pretty x. And over here, well, I'm going to look for GCF first. Are there x's in both pieces? No. But will 5 go evenly into 5? Yes. So 5 is my GCF. And 5 times x is 5x, and 5 times a negative 1 is my 5. So x minus 1 and x minus 1 are factors. They will cancel out. This whole thing is a single factor. This whole thing is being multiplied times that piece. So what's left is 5 over x plus 1. There we go. And number 6. So if you haven't tried one yet, pause the video, try it, and then you can play the video, see if you got it right. Correct your answers. All right, this looks like these two things are being multiplied together. So a minus 4 is a factor and 6 is a factor. So that part top I'm going to leave alone. So there's hopefully going to be either a 6 in the bottom as a factor or an a minus 4 in the bottom. Now this is a trinomial, so I'm thinking, ooh, it could probably be factored into a binomial times a binomial. I'll look for GCF, but this is a 1 in front of this, and there aren't a's in the last piece, so there's no GCF. So 1 times 16, because this last number, when I multiply these two together, these two numbers over here, when they multiply together, they have to equal 16. So I'm making a list. 1 times 16, 2 times 8, 3 won't go evenly, 4 times 4, 5 won't go evenly, and 6, and then we're back to 7 and 8. Okay, so this is my list of 3 possibilities for these two numbers over here. 8 is the middle number, so if I add these, I get 17. If I subtract, I get 15, not my 8. If I add them, I get 10. If I subtract, I get a 6, not my 8. If I add these, though, I get my 8. So I want a negative 8, so I think they both need to be negative. Negative 4 plus negative 4 is negative 8, so this is a minus 4 and a minus 4, and I'm about to double check when I multiply negative 4 times negative 4, I get positive 16, so it does work. Now, is there a factor on top that matches a factor on bottom? Yes, the a minus 4 and the a minus 4 can factor out, so this is 6 over a minus 4. Now, if there had been another a minus 4 on top, I could have canceled out the second one, but I can only do 1 for 1, okay? So 6 over a minus 4, and you can put the bottom in parentheses or not. Number 7, again, pause the video, go try it, see what you come up with. So we want to factor the top, factor the bottom, and see if anything will cancel out, because factors can cancel out. M plus 2 times m minus 2 are both factors on bottom already, so I don't think I need to do any more factoring on bottom. I'm hoping there's either going to be an m plus 2 or m minus 2, or maybe both of them on top. All right, so let's go do this. M squared plus 3m plus 2. So it's a trinomial, so I'm hoping it's going to be a binomial times a binomial. And it's going to be an m and an m to get m squared. And then factors of 2 are 1 times 2, and that's it. And so I'm thinking they both need to be positive to get me a positive 3. So plus 1 plus 2, and 1 times 2 is a positive 2, so that does work. So let's see, I do believe I have an m plus 2 on top and an m plus 2 on bottom, so those go away. And the answer to this division problem is m plus 1 on top, all over m minus 1 on bottom. And again, either this whole thing cancels out or nothing cancels out. I can't just cancel out the m's and the m's and the 1 and the 1. So either the whole thing goes away or nothing goes away, because remember, this is in parentheses. That whole thing is a factor. That whole thing is a factor, and they are not the same. Okay, number 8. Again, if you have not done any at this point, you need to pause the video and give a couple of a whirl, and then check your answers. So factor what's on top, factor what's on bottom, look for anything that cancels out. So I'm looking, first of all, always for a GCF. X's are not in both pieces, but 2 will go evenly into both of these. So I'm thinking let's pull the 2 out. And 2 times x will give me 2x, and 2 times the negative 5 will give me a negative 10. I can double check it. 2 times x, 2x, 2 times negative 5, negative 10, yep. And then on bottom, I'm hoping this is going to be a binomial times a binomial to get me that trinomial answer. And there were no GCFs, so I'm going to the binomial times the binomial. This is either 1 times 10 or 2 times 5. I think those are the only 2 options that will get me a 10. And I want a 7, so if I add these, I get 11, subtract, I get 9. But if I make both of these negative and add them together, I get negative 7. So this is going to be x minus 7. And, oops, I should split that to x minus 2 and x minus 5. There we go. So negative 2 and negative 5. Negative 2, negative 5. And by golly, x minus 2 and x minus 5 cancel out. So when you're done, this is 2 over x minus 2. And again, the 2's cannot cancel out because this whole thing is a factor. Either the whole thing goes or nothing goes. And there's not another x minus 2 on top. Number 9, factor the top, factor the bottom, see if any of the factors can cancel out on top and bottom. I'm pretty sure this is going to be a binomial times a binomial because the answer was a trinomial. And it's going to have an a and an a. And I need factors of 30, so you might make a list of 1 times 30, 2 times 15, 3 times 10, 4 won't go evenly, 5 times 6, and 6 is already used. And I want a 1 because there's a 1 in front of this. So that gives me 31 and 29, 17 and 13, 13 and 7. Ooh, if I subtract these, I get a 1. So if I make this one positive and this one negative, check it with the calculator, negative 5 plus 6, I get a positive 1. So this is minus 5 and plus 6. And if I multiply them together, negative 5 times 6 is a negative 30, so that does work. On bottom, look for a GCF first. There are not a's in both pieces, but 5 will go evenly into 5 and 25. So this becomes 5 is the GCF times a, and 5 times the negative 5 will give me a 25. So 5 times a is a, 5 times negative 5 is negative 25. And looky there, a minus 5 and a minus 5 cancel out. You're left with a plus 6 over 5. There we go. So there's your division. So anytime you see a division problem when you have polynomials involved, factor the top, factor the bottom, and see if anything will cancel out. There's your video on this one. I will do a video for the second page next.